Thanks everyone for coming today and listening to this presentation. And thanks for you to make such opportunity to have a talk on the like new technologies in construction. I'm quietly happy to present today the topic using the additive manufacturing technologies for construction industry, we can say overall. Because we know we are using the cementitious material, and thanks for Icons Math. Today I'm going to discuss the new innovation in construction that's like a hot topics nowadays. It's using the AM, or what we call additive manufacturing. So today I would like to talk about like the different perspective in construction, or we can say like a different perspective of additive manufacturing in construction. First of all, I'll discuss like a little bit on the AM background. So later on, I'll go to most like a famous 3D printing, which is using nowadays in construction. So, and I'll discuss some like mechanical properties because overall it's too much to discuss about it. And at the end, I'll give some like a summary for those like we are talking about. So the first of all, like if we are talking about the additive manufacturing itself, it's just sort of like 3 types. It's according to the material properties, because the materials how will act, it will be very important in additive manufacturing, whether it's a liquid, whether it's a sheet, whether it's a powder. So that's why we should like categorize it, classify to 3 parts. And in a powder one, we are usually using inkjet printing and selective laser sintering. And in a liquid one, we are usually using extrusion printing. But still, this is liquid. It can be used also for selective laser sintering. So I'll show you how it can be possible. And sheets as well, it's like a laminated object manufacturing. So the sheets like a timber, actually, the timber is possible to use for like additive manufacturing. So in these 2 videos, you may see this one is the inkjet printing, the one is on the top, and the one is in the bottom. It's the extrusion printing, which is using the robotic arm, and it can be make any geometry that you want. So the printing process, usually it's like a concept and programming and printing. So what you are using, it's like a what concept in your mind, you can make any geometry. So and decide to print, you are using the like a sort of like MATLAB or Python, and giving this programming or Reno, or there's too many others like too many softwares as well. They can be used for and connected to the printing. So Grasshopper as well nowadays using as well for this printing technology. Anyway, if we go to the first part, which is inkjet printing, it's located under the classification of powder. Inkjet printing, it is a layer-by-layer printing process, which is the water dropping onto the like a powder layer, and later on you'll receive like a reaction inside the chemical components, whether it is cement or gypsum or any other material. As long as you have an agent like activator, so which is a water and cement, will have a reaction and hydration happen. So it will be connecting those layers together. So the printing of inkjet usually takes longer time, and it needs cleaning. So it is bit like a messy process. And the powder usually it's flowing due to the gravity. It's coming from the back of the bucket, and there is a rotor inside this bucket in the back of the printer. It helps to uh, it'll help to flow the powders in the back, as you see from the video, and it will be moving this one by blader to the belt chamber and start printing on it. Extrusion printing, this process is a usually layer by layer printing process, and we are usually using the slurry, or we can say liquid type, and we have been developed this one back 2016 by using, and 2015 I can say, so by using like a Y-shaped pipe and auger inside it, and later on pushing the material. This is the first procedure that we have been done with it. Later on we have been changing this one by designing the nozzle, and we have prepared like a pump as well, like a cavity pump, and we have started printing by this sort of pump. So the extrusion printing usually is faster, and it's no need of cleaning, because once it's done, what geometry you want, you can get it, because it's no powder. You don't need to any sort of cleaning. You just remove it from the place that you want. If it's like a precast one, if it's cast in situ, so you should do it on the field or web site. And this is how we are like designing, and this is like a CAD drawing one. That's what we have prepared the pump, and we are starting the printing this way. So, and in terms of the adaptation of the nozzle, I just want to show you what we have designed and we are using, which is very actually effective for a construction industry. We have been designed like sort of like optimizing the nozzle, sort of type of nozzle we use. We usually use like a 20 millimeters nozzle head, and this nozzles we made it by like a screw, and it will be easy to replicate, or we can reuse different types. If it's like a sort of, if it's something's damage happen, we can change it anytime. And we have been using also the sort of like a ball valve. This ball valve is it's so good to use, because you can control it anytime to, if the concrete like spill the concrete, or sometimes the concrete goes flows more than enough, so you can control by this ball valve, so and connect to the hose. So this was this design that we have prepared, and it was so easy to use even for construction purposes, and it will also mitigate hazard and unsafe conditions, because if you are not using this ball valve, you need to clean all the time the head of the nozzle. So that's what we have been developing. And also there is one sort of type of printing which is under powder category, or we can say sometimes also liquid can be used. It is like a selective laser sintering. So this one is, it works by heat or laser, and this one is like a layer by layer excellent adhesion. Like it helps to like react the materials by heat, or we can say by source or heating. And this will usually prefer to be a powder, but we have been actually using paste. I've been using paste or mortar at student university. And SLS can be subjected to high temperature, and it will be cause shrinks. And as you see in the figure on the right side, we have been using like a different lights and different speeds. So the source of the heat we have been using, like we can focus it in a higher or lower, like a aperture. It's like a light of source that goes through the the hole, it can be reduced or increase it. So the first one is like a cutting. So it could be like used as a subtractive as well, not just additive. So, and these others, it could be like using as a source of heating to cure, and you can make another layer on it. And this actually, this type of SLS, it's not really famous because of like a light that they have. It's a laser usually. It's dangerous, and also it's expensive when it's scaled down to smaller type of printing. And I'm going to talk a little bit more detail on Inkjet 3D printing, which is called powder-based 3D printing. Sometimes it's called binder jetting printing. So here is some result that we have been received until now for like compressed strength of the mortar. For the mortar, you can get even higher if you make a proper material together. So anyway, we have been get it 37 megapascal. So when we are cured after we have been done the like a printing process, so you have been cured in 80 degrees, later put it in a water, later on you put it in a oven again at 80 degrees, you get very good result. And this can be done also straight away, but you maybe like after putting to the water, but you maybe not get the result that you want. So usually we know the compressed strength for construction purposes is pretty crucial to have. So anyway, we have been done a lot of tests for compressive in regarding we have been using like our ordinary Portland cement, calcium aluminate cement, and sand as well. And for flexure, we got like a different results in like a different direction. So like X, Y, and Z direction. After cured, we have been get like about 6 megapascal somehow. But still, we are working on this project, and we have got some other results. So for extrusion printing, we have been used actually this sort of mixed design. For the mixed design that we have got like fine sand and cement and retarder, sometimes like a sometimes super plasticizer. It depends how you use the design. So and the delivery method, we have been using like different types of the methods like collecting gun, and we have been used also pumping process. For those to get a very good like or optimum mix design, you need to do few tests like a squeeze flow test, and like also slump test, a mini cone, we can say slump test, and flow table test as well. So we have been published a few papers in that regard. So and for particle size distribution is pretty like significant to consider, because the distribution of those two, like a fine sand and ordinary Portland cement, could receive or better or packing of particle model in your system. So that's very important even for both procedure, like for inkjet printing and extrusion printing as well. Anyway, in extrusion printing also we have been done so a few more tests, is like we have been compared like a short column or hollow column, I can say, and we got such result. The result is for like with the polypropylene fiber PP, and without polypropylene we have been done, and we have been used also E6 glass fiber. So I'll show you later on what we have been done on the E6 glass fiber as well. So the here's a sort of like a printing we have been done here, and under the loading. So, and the results for compressed strengths with the PP when we have been using like one layer, double layer, or triple layer, or 4 layers. So we have been got like various results, as you can see for flexural. So the results not really when it's increasing the layers, the result of the flexural reduce, because we have been figuring out there is a lot like a gap between the layers, and there is like a lot sort of porosity inside the layer itself. This is usually due to the chemical compound that you've been using, like whether you are using retarder, super plasticizer. Anyhow, we are recently, this is sort of comparison between the isotropic mortar and the orthotropic mortar. Well, for those two types, we have been figured out the ones we have printed, it's almost for flexure 5, but sometimes for isotropic for the same mix maybe goes to 18. So it's a very like inconvenient, or we can say it's very low result compared to the isotropic one. But we have been improved this way by using the E6 glass fiber. This glass fiber, it's worked pretty well, and we have been used for first layer, 2 layer, 4 layer, 6 layers. So we go like 31 megapascal. But still, this is for compressive one. But still here for normal one, when we have been testing 50 by 50 cubes, we got like the original result of 51 megapascal. So the grade's almost 50 megapascal, but when we have been using the printing, still there is lower result you maybe get. So that's what I've changed this sort of geometry from the hollow columns to make something like a uniform, like a cubic. So for flexural, the flexural is actually here is a bit better in a E6 glass fiber. We got like a 9 megapascal, and for the ones we have been prepared like a prism, we got like about almost like a 9 megapascal as well. So almost similar or same in the flexural terms. However, sometimes you may be seeing like a small like holes between the printed layers. So this is because of like a printing of the layers. So it leaves sort of gap in between those two layers when it's adjusted to each other. But this may be not used in a real life. You maybe have a different geometry like a hollow column or different types. So this is just to show if we are making like a 2 layers, almost you maybe have a sort of a hole or gaps in between each layers. And in terms of selective laser sintering, we have not been done too much in this type of technology, but it's really important to have a future work on such technology, because it seems nowadays they are providing like a different type of SLS, so in a small scale and larger scale as well. So, and I was thinking to use sort of like a powder type of cementitious material, which will be promising, with maybe getting that promising result in future. And this types also you can be used it like a mortar type or liquid type, because it is possible to be used. And I was thinking if sort of modification maybe happen, like a bringing the bladders, bringing all the liquid materials on the top, the second layer, and we maybe sort of have a cutting as well, and we can maybe have a curing at the same time too. So this is sort of like a SLS innovation. So but this technology bit like dangerous because of using lasers. So people maybe don't like it too much to work with this sort of technology, but this is promising, especially for the like a out of the or like a planet, for example, for Luna, like using on the Mars or Moon, it is promising, and maybe we get a very good result. So that's regarding SLS, like selective laser sintering. And to finalize my like a presentation, I was just saying for each like a type of materials that we should use, it's very important to use an appropriate technique or technology. Otherwise, it maybe not work properly, or maybe takes longer time to receive or to get or achieve the property that you want. Especially for us as engineers, we are mostly focusing on the mechanical properties to get a very high results in compressive and models of plasticity. And the second point I can say, it's very important to optimize the time between layers, which have been done for Inkjet 3D printing. I've published one of the papers, so we can optimize the time between layers as well. And adhesive agents, it's very important to use what sort of agent you are using, whether you are using just water or super plasticizer, and saturation level as well, which is water to cement ratio, and pumping and jetting. So for example, in extrusion, we need a pumping. That in inkjet printing, we are needing the jet at sort of to splash the water from the head of the printer. And printing the right geometry, it's very efficient because it may save a time and material too. And additive manufacturing itself could be broadly used in other other types of the additive manufacturing, possibly to be used in near future as well. I'm pretty sure there's few other types of the AM will be very helpful for construction technology. And that's end of my presentation. And I'm not sure I'm finished on right time or not. So okay, I think yes. Still we have